Live. Yeah, so there's a ton of stuff left to cover. I mean, so we've really what we have really focused on this time, this semester have been the real core programming basics. So things like loops, if else, all the variables and data types of variables and so on. That kind of core key programming knowledge type stuff. There's plenty of other stuff that we haven't yet gotten to, like functions, modules, other kinds of data types. I think we might get to one of those today. But do people that haven't ever programmed before, do you feel like this is helping you kind of reason through stuff? Is this kind of helping you feel slightly less scared about new languages and things? Or is it still kind of freaky and intimidating and weird? And I don't know. What do people think? Feeling okay?
Yeah, I think the basics make sense, but on thinking about long term, if I were to program my own task, how that gets done and how I export data to an Excel file and things like that. So
yeah, I mean, yes, there's a whole this is just the beginning of your steps into a larger world.
I definitely think the basics make sense.
Yeah, and I'm not sure. I guess we'll have to figure out if people want to continue with this kind of stuff. We can keep going either next semester or over the summer or something. Mm.
This is the type of thing that once you know the basics, isn't it pretty easy to access or look up in, because isn't at least Python has the directory of commands and stuff.
Yeah, I mean that was sort of my theory, is that essentially, once you know kind of the concepts, it does get easier. I laughed because I just started actually for fun. I was looking up some stuff in Swift, the new programming language that Apple just invented, and their book on Swift starts out with an extended description of the language, and it's pretty weird compared to other languages I know. So I'm oh, this is what it feels like again, to be just totally not remembering what any of this stuff means or whatever. So, it does get easier. I always say it's like learning a foreign language, right? You have to get kind of the basic, kind of language structure down. And then you can build vocabulary forever, but definitely building vocabulary becomes easier once you have the building blocks. And then learning a second language, a third language, and a fourth language, each new one kind of makes additional ones easier because you kind of have the basic skeleton in place. Hello. Please help yourself to some pie. There's plenty of pie around. Okay, yeah, so maybe we'll keep going, yeah, so there's plenty more to learn, especially in order to be able to fluently read and write code. But yeah, what my hope is that people aren't scared by the basics, and then you can kind of keep going more on your own. Okay, well we'll probably have at least one more Python-y thing either in between the R sessions, because we have a week off there, or after the R sessions, but that's good. So I do have some Pi-related exercises for Pi Day. By the way, it's Pi Day, 3/14, except in Europe and most of the rest of the world, where it's just a day. Okay, so what's that?
Makes more sense to go day first. Is it really not celebrated anywhere else?
I assume it's celebrated on the third day of the 14th month in other countries, but I don't know. No, I don't know.
31st day of the fourth month.
Yeah, I don't know. I think other people begrudgingly accept the American convention for our Pi Day. I also don't know what they do for Mole Day, etc. And of course, June 28th is going to be Tau Day. If you listen to those nerds on the internet who argue that Tau, otherwise known as 2 times pi, is a more reasonable number to use as our universal constant than pi, but whatever, those guys are nerds. There's this whole debate about tau versus pi. I don't know if you guys have run across this yet.
No. I'm just laughing because you know about the debate.
Oh yeah.
So it's not so
not only do I know about the debate, I have an opinion. So I know I'm not innocent here of nerdery. No, but all right. So I do have some Pi-related exercises. This is not helping my lack of nerd cred, if what I'm about to say next, but. The exercise I figured we could do. So at least one of my favorite things to do, this might be the only one we have time for today, or one of my favorite little facts about pi, pi with no E, is that I was going to make a joke about E, the constant, but I held back. Is this. So does anyone know like how you could derive pi, like a way that you could get the digits of pi, besides like calling a pi function, like that somebody already wrote? Does anybody know how a way you can?
Hypotenuse of a triangle or something like that. You make it into triangles or something like that.
Yeah,
I think
that's like a circle.
I don't know that one. How does that work?
you basically like I don't know either. Like it's been so long. Like you somehow put triangles in the thing, and you seem like a radius of 2 or diameter of 2 and a radius of 1.
Oh, and
And then you're able to figure out like
successfully approximate the
Yeah.
ratio with triangle math. Oh, that makes sense, I guess. With like the fact, with like a bunch of applications of the Pythagorean theorem.
Yeah, I was thinking like the circumference of a circle. If you knew.
Well, you could certainly like
Yeah.
do what they did like back in the day, which is like measure circles and calculate the ratio, I suppose. Yeah, and actually, yeah, that I vaguely remember. I guess people talk about like you could approximate it with like a bunch, like a 12-sided figure, a 16-sided figure, or a 100-sided figure that you can do like triangle math to get the essentials.
Oh, yeah, I think like you put a circle inside of a square, and like you see.
Yeah, there's that whole squaring the circle thing.
Yeah, I don't know.
Oh, I should tell you. I forgot about this, but I should tell you guys before I forget. An excellent book, if you're actually a dork, is this even has its own Wikipedia article. Oops, I totally misspelled that. History of Pi. There's a great book. I always said when the book The Life of Pi came out, I was disappointed because it was not like a historical description of the number pi. But there is actually a book called A History of Pi, which was a book written in 1970 by this guy, Peter Beckman, that is a history of the number pi. It's actually kind of interesting. But the really funny part about it is he's this guy who fled the communists to come to the U.S., and this book that is like ostensibly just a history about a mathematical number is like peppered with like these vitriolic comments against communism. So it'll be like, the ancient Greeks had blah, blah, blah culture, filled with math and blah, blah, blah. Unlike the godless communists. And then it'll like just go back to talking about math and history. It's a weird book. I highly recommend it to anyone who wants to read it. Because it's just weird, like the politics creep in around the discussion of this number pi. All right. But anyway, so the thing I was thinking of, which is kind of a weird mathematical fact, and I don't quite understand why it is, but it is that pi can also be calculated as the sum of the infinite series 4 minus 4/3 plus 4/5 minus 4/7 plus 4/9, ... right? Yeah, freaky, huh? So the longer you extend that out, obviously, the more precise your estimate of pi gets. And I don't think this is a particularly efficient way to calculate pi.
So it would be minus 4/11.
Yeah, minus 4/11 plus 4/13 and so on, right? So my question to you guys, so my first pi-related exercise of the day is, if I open up PyCharm, is how would we do that in Python? Yeah, day full of pi. And it's not that hard. So, let's decide. Let me just open up this project here that we had before. So we get a window. Okay. This is like, this room is driving me nuts. Like the pirate joke. So if we make a new file, so we're going to have to make some decisions. First of all, right, oops, what the, count pi.py. All right, so let's actually not make this quite full screen because it's too cut off there, but there we go. Okay, so how would we think, let's kind of plan out how this might go in Python if we want to calculate to some precision the value of pi from, from this series. So how could we go about doing that? What we need to do. This is not going to be a terribly long or difficult program, but we do have to think about what it's going to be first.
First, I have to decide like what do we want to stop at.
Okay, yeah, so how long we want to go for. So what basic like programming concept are we going to have to employ to get this thing done? Do we think? Like what kind of basic structure is this program going to have? I'm going to fill up on pie. I don't know about you guys. I don't have lunch.
Well, the denominator is the only variable, so you have to make that into a variable.
Okay, so we have to have a variable of the denominator that like increases over time. And to use that, we would employ, or to like make that happen, we would employ what like kind of structural, what's that? Yeah, like a for loop. Okay, so what are we gonna, so start telling me what to type. Let's figure this out together. I don't want to give you too much help here. I'll let you guys kind of work this out.
Where did it start at again? What's the thing?
So it starts with the number 4, and I'll give you a little hint. Hint 4 can also be expressed as what in this series to make it even more kind of consistent with, yeah, so really like it fits better into the series if we express 4 as 4 over 1, right? So 4 is not like special in that series really, it's just divided by 1.
And we also have a floating number in there, so otherwise it won't have the, or never mind, it's already implied. No, it's not implied. So
well, we do, yeah, when we write it, so that's just writing it like numbers, but yeah, when we write it in Python, we do want to make sure we express everything as floating point values, right?
When you say like a range, can't you give it an interval too?
Oh, like do a range? That's a good question, actually. I think you can. Like, let's see, Python range. Right. So one way we could do this, I wasn't thinking that we would do this way, but we can. So you're saying like you want to make your range go by 2s, basically, right?
Yeah. I mean, yeah, it'd be easy to do it after you set the range.
Yeah. So let's go down to range. I think there is a way you could give range some extra parameters to make it go by 2s or whatever. So yeah, start, stop, step. So let's actually try that here. That's a good call. So that's probably how like you would do it if you were clearly an expert Python person, because that would save you some steps probably. So like range 1, 12, 2, right. So this very MATLAB has a built-in thing that's very much like this, right? So that's one way we do it. So let's say we'll maybe just do the denominators up to 11 for now and see how precise an estimate of pi that gets us.
Wait, why does 1 12 2 turn off as 1 3?
Okay, so
1 to 12 go every 2.
Oh, okay.
yeah, so the third thing, so normally we've just been giving range 2 things, but now we're giving it 3 things, and the third thing is what to step up by, right? Now what that won't give us is that alternation between plus and minus, right? We'll have to do that ourselves. But at least we won't have to like handle the counting up by 2s by ourselves. So, going back to Python.
So I'm thinking R, so this is probably not the best way to do Python, but like if you create an array or a list, how do you call items from that array? Like
Yep. Well,
thing
we
number
haven't.
1, thing number 2, thing number
Yeah. Well, I mean, so we haven't really, and this was maybe going to be the more sophisticated thing I got into, although I think we probably won't get to it today. We haven't really talked too much about lists and such in Python, except in terms of like what you're doing in a for loop.
Mhm.
Because that's essentially what a for loop does, right? Is it takes each item out of that list that we just made with range in sequence and puts that into your like list or your loop variable, right? Now we haven't, yeah. So like the more sophisticated way of doing this, because what we're going to learn if we do this right is that if we use regular like kind of floating point Python variables, those are going to max out at a certain number of digits, right? So if we want like 1,000 digits of pi, we're going to have to create our own way of representing those digits, right? Because it's not going to work to use like the standard variable type, right? But where did I go with this? But right, but we don't have to, except for the for loop, we don't have to use a list for this. Now I don't know, like, will a for loop do the job you were talking about? Like,
Yeah,
pull
I'm
that
just
1 3
thinking
5.
like if you had like in the denominator you can have like start with I, and then the next step would be I plus 1, and I would be the thing in the list, so that it starts with 1, then it goes to 3, then I plus 2 would be 5, I plus 3 would be 7, so on and so forth. Does that make sense?
I think I sort of got what you're saying. All right, well, let's start, but I think we can do it. I think we can do this very simply. We just have to think through it. So let's do this. So let's do that range thing that we just did with the step by twos. And let's call our loop variable denom, as in denominator. 1, let's just do it up to 12 by 2s like we did before. Right, so that will do, I mean, this is not going to do anything just yet, but except print it out. But let's run this and step up from there. So, right, that'll give us our 1, 3, 5, 7, 9, 11. Now, like you said, so like we said, we're going to have to like alternate between positive and negative for these. So what could we do to get some alternation between positive and negative in here?
If you took out the step from the range, then you could do like you could just do, it might have been what you were kind of saying. So like if you didn't have it automatically do the interval and you just set the range, then you could just call each, like you could call the first one and make that positive and then do plus 1 and then make that one negative and then just make it go back through the loop.
So so you're saying do 2 steps each time through the loop? So you could do that. You could do that. And you could still do that with the loop. You could just do it like stepping by 4s, right? Because like,
yep.
You know what I mean? Like, so you do a positive 1, then add 2, and then do a negative 1, and then the loop variable needs to go up by 4s in that case.
Yeah.
There's another way you could do it, though.
If you could do, I'm trying to think if like if there's a pattern to what you're subtracting and adding, you could do like if this number is like divisible by 3 and there's no remainder,
Okay.
then we subtract it.
So that would have been, I think that's the thing to do if we're going up by 1s. But now, and that's sort of what I was thinking along the lines of what we would do. But now I'm pot committed to going up by 2s. So like if we're going up by 1s, we could say like every time the loop variable is even, the multiplier is positive. Every time it's odd, the multiplier is negative.
Yeah.
But let's say we're committed to this. So yeah, what were you going to say?
Could you have a separate variable count up each time goes to that loop, and then you look at that variable to see if it's even or odd?
You could. So I like the idea of a separate variable. What is a way, though, that we could have a single variable that kind of flips from positive to negative?
Negative
Just
1,
sure.
negative 1.
What's that?
Just negative 1 multiplied by itself will alternate.
Okay, right. So if we said something like, we called a variable like sine equals 1, and every time through the loop we did sine equals what?
Negative equals, so it would be times, not down, right? Negative 1 times.
Yeah, something like that. Actually, let's start it with, let's put that at the end of the loop, because actually we don't, well, this is something we would have to decide, but let's put it at the end of the loop right now. All right, so, and then print sine. All right, so if we run this guy. All right, so that successfully gets us 1, negative 1, 3, 1, 5, negative 1, 7, 1, 9, negative 1, 11, 1, right? So if we wanted to say this basically, take out the print sign and just make this print denom times sine, and run that, 1, negative 3, 5, negative 7, 9, negative 1. So that's a promising start, right? Now, do you guys see why I wanted to put sine equals negative 1 times sine at the end of the loop? What happens if I put it at the beginning of the loop?
It hasn't been altered.
So if I put it at the beginning of the loop, what is my output going to be if I don't change anything else?
Reverse.
Maybe negative 1.
Yeah, so it'll be -1, then 3, then -5, and 7, right? Or, I mean, if we did want it at the front of the loop for some reason, we just started off being -1, right? And we get changed the first time through the loop, right? So either, right, and this would get us back to what we want, I presume, right? Does that make sense to people so far? All right, so now we have the denominators correctly working here. So what do we do to calculate pi with this kind of basic loop structure?
You have a variable with 4 divided by the denominator, always adding.
Okay, so we could say something like, you know, my pi equals my pi plus 4.0 to make it a float, divided by denominator times sign. Okay, and there's one other thing we might have to do to make this work. Oh,
Make pi variable.
okay, yeah, so we need to make it be something at first. So what does it need to start out as before the loop?
And just be empty.
Yeah, it can just be 0, right? So, yeah, empty has a special meaning, sort of, but we mean like numerically empty, right? So, and let's make sure that is also a floating point, so let's do 0.0, right? Because we want to make sure it is a floating point variable. So let's see what happens. Let's just change this print to my pi. Just take out that print so we only see the values of pi. Is this working? Well, hard to tell. Let's crank it up a little bit. Well, these look like 4, 2 2/3, 3 and whatever that is, 2.89, 3.3. These do look like they're getting closer to pi, right? Interesting. So they're 10 times longer. Wow, computers are fast. Let's go 100 times longer.
There's some, it's like repeats and
Repeats, you say?
No, they're two numbers different.
okay, this is hard to go back and forth, yeah.
1 and 3, 1, 3.
Yeah, 3.139.
Yeah, so if we were doing something with like graphical, whoops, what did I do? Graphical powers, we might be able to like print this in the same location on the screen every time. Oh, that guy was going fast.
Go 4 places.
Yeah, it's like those old movies where they're like locking in a password. Here, let's do it this way. Let's just do it like 999999999. That probably won't go
I
that
think I
long.
just crashed mine.
Oh yeah.
Yeah, I did a billion.
Yeah.
So probably. Oh yeah, it's not liking that, is it?
1, 2.
So we probably have hit the.
9 zeros.
Let's see, is it even running? I don't think it's even. What is it doing? But I don't know what you're doing. Just decided not to. Yeah, because we actually are running up against the limit for integers. So actually, the limit for integers on a computer, depending on how this is implemented, which I'm not quite sure, is around either 2 billion or around like 4 billion. So that's 2,000, 2 million, 2 billion. That should be okay. Do you guys?
That there's no decimal
What's that?
in that part. Because we're dividing the 4.0 by it. So
Yeah, so that makes everything be
so
a floating
it's
point, like it'll
within-
convert everything
okay.
else. Oh, well, actually, yeah, I think we're okay there. Yeah,
It's within the same operation. Isn't it?
yeah, exactly. So, like sign and denominator are both integers at this point. So that stays an integer, but then when the integer gets divided with a floating point, it does the whole operation as floating point. So that's safe.
Okay.
So let's see if that'll run. I think it should. Do you guys remember when like the Gangnam Style video? Oh, it did not like that either. Let's see.
8 digits work.
Let's just see something. Oops.
Doing a video from YouTube, their country book for the number of views.
Oh,
Yeah, there's-
So it is running. It's just, oh wait, maybe it's just not printing each time. So what this was doing is,
Doesn't it say stuck or did JK?
yeah, so it's doing something very intensive right now. Or it's Python is taking like 30% of the CPU, but it's not actually printing. So probably what's happening is PyCharm has decided like it's not going to actually print the output till it gets done running, and that's not what we want it to do. Because sometimes that's something that, oh dear. I think I have, yeah, I am doing bad things to my computer. Welcome to programming.
This morning I had PowerPoint and Word open and my computer just couldn't take it.
Wow.
That's, you gotta watch out for crash plan. I learned that crash plan, if you have a lot of files, just takes like more memory all the time. So now my crash plan is taking up like 2 gigs of memory. Not good.
What if you move the print out of the loop?
So
then
yeah,
could
so
you run it more? Because then it's not trying to print every time.
so that is certainly one thing we could do. Let's also maybe take it down by like a factor of, let's take it down by like a factor of 100. Make it what, 20 million?
Boring.
Let's just see how long that takes to run. Probably it's going to run a lot faster. And actually, if we look back and see, probably, if we look at my CPU usage,
It's already done. So.
that was already done?
Yeah.
Ah, it's too fast for me. All right. So this is looking pretty good. 3141592.5. So,
Yeah, it's supposed to be 2.6.
I have
So we'll round up from that.
all right. So let's go 10 times longer because clearly that wasn't long enough for me to even tell. But what you should see is like, it wasn't taking up a lot of CPU before because probably it was like trying to store all those like print statements in their output to memory. What's that?
Up to 95%.
Yeah, which is what it should be, right? Like QuickTime and the kernel task, which are what are doing the screen recording, are taking up a big chunk of CPU also. But Python is now like the big one. So this is kind of like an implementation choice by PyCharm, basically, which is that like when you tell it to print, it's actually not printing like the instant you type it. A lot of times, like output is sort of queued up and printed out only after it like lets go of the CPU. So that's what it was doing in that case. That's why it's not printing each time. You guys might have found this if you ever like ran a MATLAB script or something like that, and all the output comes spewing out at the end. We could probably change that with some kind of preference or setting, but we won't. So in theory, well, so this is a good question to bring in here. How's the berry pie thing? Good?
Very good.
All right, I'm going to try this thing. You guys got to eat more pie. Right now, I'm eating more pie. I have a real problem with that. Oh no.
Yeah.
I might have to bring up the big guns here.
Crazy.
So in theory, how much longer should it take to run? Oh, okay, it's done now, right? So how much longer should it have taken to run this time relative to last time?
10 times longer.
Right, because we're doing stuff that is, we're looping through 10 times as many values, right? We're running 10 times as many loops. And we aren't doing anything within the loops that takes a different amount of time depending on what loop we're in, right? Now, if we were doing something inside the loop, so like, remember when we were doing our prime thing, how inside the loop we had a loop that counted up within it? Does that, you guys remember that? So like, if you're checking to see if, whatever, 17 is prime, we were counting up like all the numbers within, like less than 17 to see if they were factors of 17. Does that ring a bell to people?
Yeah.
So think about that. Like, is that going, so if I'm testing to see if like say 1,000 is prime versus 10,000 is prime, is that going to take just 10 times as long? Hey, let's be crazy and just go another 10 times longer while we're talking about this.
Well, you have 2 loops in that scenario, so it might take more than 10 times longer, however long you said.
Okay, yeah, so let's think about that. So let's say, I forget exactly how we did our prime thing, but we said that, basically we said if, like let's say you're testing, to see if 100 is prime, you basically count up all the variables like in that range up to 100, and see if they're factors, right? So if you're testing to see if 100 is prime, you have to basically test almost 100 numbers to find that out, right? Now we had some tricks to like speed it up, right? We could only test odd numbers or whatever, or only odd numbers besides 2. But if you're testing 1,000, you have to test essentially 1,000 smaller numbers